Hi, my name is Louise Campbell and I work for Marine Scotland Science. And during this presentation, I will talk about the Scottish Shelf Waters Reanalysis Service, which is a downstream service of CMEMS, which provides a 25-year hindcast of the Scottish Shelf Model. This project is a collaboration between us at Marine Scotland Science and the National Oceanography Centre in Liverpool. One of the reasons why we at Marine Scotland Science use hydrodynamic models is due to our commitment to identify potential economic development areas in the coastal and offshore marine environment, while avoiding conflict among users and ensuring sustainability. So as an example, a hydrodynamic model can be an extremely useful tool when generating an environmental impact assessment before installing a new fish farm or new wind turbine site. So hydrodynamic models provide us with evidence-based input, which can be really important. The Scottish Shelf Waters Reanalysis Service is based on the Scottish Shelf Model, which is a regional hydrodynamic model covering the Northwest European Shelf and is an implementation of the Finite Volume Community Ocean Model, or FVCOM. One of the benefits with FVCOM is that it utilises an unstructured grid. The benefit with this is that the resolution can be adjusted according to your requirements. So in some areas, for example, close to the coast, you can adopt a very fine resolution, while further out at sea, you can adopt a coarse resolution. This is extremely beneficial and saves computational efforts. The suite of models included in the Scottish Shelf Model contains not only a wider domain model, which covers the whole of the UK, here highlighted in grey, but also several smaller, finer resolution models. These are all nested within the wider domain and can be run either forced by the wider domain or run independently. If you want to know more about the Scottish Shelf Model, you can find out more by going to our website. If you Google the Scottish Shelf Model, you should find yourself in the right place, but I will also put a link up on my final slide. Model outputs from the Scottish Shelf Model are available to the wider scientific community, and the main available output from the Scottish Shelf Model is a 1-year model run using climatological forcing to represent an average year. So this forcing has been averaged over a 25-year period and applied to the model, which has then been run for a single year. The benefit with this is that you only have to run the model for one single year and you get a product which represents average conditions. The disadvantages with this is that you lose a lot of information in terms of seasonal and annual variability, which in some situations can be very important. As an example, storms, which can have a large effect on the hydrodynamics, are all smoothed out over a 25-year period, since they don't always happen at one particular point in time every year. And in some situations, it can be very important to capture this information, especially when doing tidal energy resource assessments or connectivity studies which rely on particle tracking over the winter months. So this has limited the potential usefulness of the Scottish Shelf Model, and this then takes us to the Scottish Shelf Waters Reanalysis Service. So the objective with the reanalysis service was to produce a 25-year hindcast of the wider domain Scottish Shelf Model, where the model is forced using CMEMS products. As I mentioned earlier, this is a collaboration between us at Marine Scotland Science and the National Oceanography Centre in Liverpool. And the model runs have been developed and are executed by NOC, while Marine Scotland Science are responsible for the dissemination and demonstration of the service. And as a result, we will have 25 years worth of model output spanning from 1993 to 2017. And this will include both hourly and daily means of currents, sea surface elevations, temperatures, and salinities. Most of the model outputs should be available for download sometime at the end of November, and this data will be freely available to anyone who wishes to use it. A product like this, which includes the interannual variability, will improve accuracy and also increase the usefulness of the Scottish Shelf model. The existing climatology, where the forcing has been averaged over a long time period and then applied to the model, running the model only for a single year, is hard to validate since you can only really compare it to other climatological products. With this new hindcast, you can perform a more extensive validation, which will then increase the user confidence. So we are really hopeful that many will benefit from this improved 25-year model run of the Scottish Shelf model. So this is kind of the different stages of the project. So the first step was to build boundary conditions. The next step was then to set up the assimilation, to then go on to building atmospheric forcing and freshwater forcing. The model was then calibrated and validated before the model was set running for the full 25 years. CMEMS products were used in 3 of these stages. So the CMEMS products were used in generating the boundary conditions for the assimilation as well as for the calibration and the validation. So in total, there are 6 CMEMS products used for the reanalysis project, all listed here. These have all played a vital role in generating a product with high user confidence and accuracy. So this list includes a combination of other hydrodynamic models as well as some observational data sets. So to generate the boundary conditions, the majority of the information has come from the Met Office AMM7 model, and for the assimilation and the calibration and validation, the data products that have been used are based on observations. Some applications will really benefit from this new and improved product, especially applications where interannual variability is important. I thought I'd mention a few to give you a flavour of the versatility of the model. So first of all, we have the assessment of impact of renewable energy installations. So this will include things like assessing and modelling how much energy can be extracted from tidal turbine installations and what possible effects this can have on both near field and far field hydrodynamics. Another example is using the Scottish Shelf model for connectivity studies for aquaculture or benthic species within marine protected areas and other habitat areas. So this involves using the output from the model to force particle tracking simulations. And this allows you to predict connectivity between different areas for different species. And this has previously been done looking at, for example, sea lice dispersion or horse mussels and flameshell habitats. You can also use the Scottish Shelf model to force smaller local models. We do this in-house to force our subdomains, and others do it to force their own smaller local models as well. The Scottish Environmental Protection Agency, SEPA, used the Scottish Shelf model to force their MIC models, which they then used to determine the suitability of an aquaculture proposal based on the resulting waste dispersion from multiple sources and the risk posed to sensitive features. So this is regularly done by SEPA when screening new aquaculture site applications. The model output can also be used for emergency response in the case of, for example, an oil spill in the North Sea. And there are loads of other applications where the Scottish Shelf model can be used, and it's already playing a vital part in many research projects. We hope that this extended model run will increase the range of Scottish Shelf model applications. If you're interested in the reanalysis service, or if you want to know more about how the reanalysis service is set up, or how to access the data, or anything regarding the Scottish Shelf model as a whole, you can go to our website, or you can send us an email and we are happy to answer any of your questions and assist you into accessing the data. Thank you.